Okay, so I have already shared the notebook with you, and we will be now shifting to application of this, that is applying ML, machine learning. So for that, we have actually seen the data types and how the functions are there and all. Uh, Most important part, or one of the most important part you can say, is your NLP, that is natural language processing in deep learning or machine learning, AI, whatever you call that. Okay, so when we get data, the data could be in text form or numeric data, integers, whatever. Okay, so if it is a string, that is your text, then it has to be actually converted. Your machine learning algorithms won't take it directly, so you have to actually convert them. And then you have a lot of other processes which we can perform on your text, like you analyze the text, that is what we call the text analytics, also text mining also. And this you can actually find out the mood of a person. You can but before you do that, you have to actually get the features out of it, right? So some textual features are there, and we have certain algorithms also, and you can get those to detect a lot of things, like the mood, as I said, mood of a person. So you can find a lot of things, and we'll discuss all that. So text analytics or NLP, natural language processing, involves few tasks, like you have to break and all. So we'll come to that one by one. And the package use here is NLTK, that is the module. And NLTK is a very strong package, and we use it most of the time in text mining. But it is not limited to text mining like what we did in the strings, like simple string commands. We can use that also, right? But that gives, that has some limitations which we don't want to have. Okay, so let me see if I have shared this. Yeah, it is already shared. So NLTK is there, so you can see that. The natural language processing, you have to see what is text analytics and NLP, compare text analytics, NLP and text mining. So all same thing, analyzing the text, future trends, and you can do a lot more. And we have certain modules now in deep learning. We that is not now, it is almost 5 years now. We have it, and we call it PERT, and that is the most interesting and most powerful package module we have now, and a lot of people use it. We will use it also, although deep learning is not in your course, but I'll show you because you'll love it. And we'll not go into the details we have of that. We have certain modules through which you can apply BERT on it. So you don't have to go into the details of BERT, not in your syllabus, but it's okay. You should know a few things, because we go by the things. And actually, let me first put it. Uh, we will not be with the market. Okay, so people are using transformers and we are using machine learning. So that does not make any sense to the market, right? So they will not be using machine learning, but machine learning is the basic to understand everything. So you have to do it to understand how things can be applied and to understand what AI is all about. Okay, so let me see if I can import directly an LTK if it is installed with the Colab. Otherwise, I'll have to uh, install it. NLTK. Let's see. I'll just run it and see if it gives me an error. That means the module not found, and I'll have to install it. Pip install. Otherwise, I can use it directly. There are certain stages in deep learning, in NLPK, that is natural language processing. NLTK I'm using, sorry. This one it's okay. Now it is working in NLTK. You can see that NLTK has given a green tick to me. That means the module is already installed. But suppose you want a different module than what is installed, then you can actually install that particular module by saying pip install NLTK equal to the module number. So sometimes it happens that your commands are not working because this is a newer version, because Colab actually automatically updates itself. But you have certain commands which are not working because the module they were used were older ones. So if you want to test them, you can always install the older version also, but that will be temporary. The moment you close your Colab, everything resets. Okay, so you must have observed that also. Even if you upload your files, your data, that also goes. Okay, so let's do something. And here the first thing in NLPK, NLP, sorry, natural language processing, I'm using K from NLTK. Anyway, sorry, it is NLP. So in NLP, first thing is tokenization. We have done it yesterday also. We tokenize that, and I think it just give you how what token means. But in any case, we'll just do it again and do it using NLTK. And tokenization is breaking actually the sentences into words or alphabets. Right? A sentence has to be broken, otherwise you cannot make any sense out of it. Right? The first thing is tokenization. So you have to tokenize, and for tokenization we have NLTK. We'll be doing that, but before that, let me put what tokenization is, so that you can read it later. But tokenization is breaking the sentences into chunks. Okay, and chunks here actually is your words. Okay, now we need some punctuations also. So we will be importing that nltk.download punct, punkt, punct is punctuations. So let's run it and download. It has to be downloaded every time actually in Colab. So we have to download again. So I've put it. Now we have to from nltk dot tokenizer, tokenize, import. From the module, you have to import sentence tokenizer. Sentence tokenize. Sentence tokenize you have imported. Now let's have a text. And let me get it from news. Okay. Let's see some news. And we keep getting certain news every day. Okay. Something on Russia we have. Okay. I'll just take it. From here, I'm taking the news, which I'll put it in that text. If it is big, it's okay. So it is talking about the US intelligence believe a rapid assault on Kiev was also possible, and that Russia President Vladimir Putin could order an invasion. So these days, this news is hot that Russia may attack Kazakhstan or areas around that. Okay, now we have to tokenize. It's very simple. So tokens ke liye we can take this tokens available, and then we have to tokenize using the command sentence tokenizer, which we have already used here. So I'll just put it here, copy that, paste it, and put my text inside that. Simple. Earlier we had to write all the codes to tokenize. Okay, this is working now. I have to print it. mute few things. I thought I have. Let me mute it. Okay, that's fine. Bad habit. Okay, now let's print and check what is there in tokens. We'll understand why we use it once we will put them machine learning. Okay, so this is one sentence, big sentence, so you can not see much here. It is one sentence. So sentence, it is actually converting into a list, but we have to tokenize the word. This is a complete sentence which is actually broken up, but you can see that wherever there is a dot, there is a comma there. Okay, you can see that commas are there. It has been it is divided. You can see that this one comma. There's no dot actually. This is one complete sentence. Possible. I'll just put it here. I'm just having one more sentence and I'll run it now. Now you can see. So one sentence broken up, and then we have another sentence here. So two sentences. So sentence tokenizer breaks into sentences. But this can be useful, but I would like to have the words. Okay, so we need word tokenizer, and for that we will be using another module. Let's have it. So this was sentence breaking into sentence. Now from I'll just copy this. I'll copy everything. I just have to change actually the sentence. Instead of sentence, I have to change it into word. I have to change to word, so I type everything again. And now it is word. And you can see that the text can be same. Okay, just run it. You can see this now. Everything is broken into words. Tokens, single quotes means one. Length you can find out. See if I can find the length of this. Once it doesn't work, it will give you some errors. Let's see. 44. You can see that there are 44 words in this. You can find that. Okay. And in this, if you want to find the length of tokens, you can see that it would be just 2. That is 2. Okay. Because there are two sentences in this, there are 44 words and they are called tokens. So sentence tokenizer or word tokenizer depends on you what you want to use. Now what can we do now? We need the frequency of each word. Suppose that how many times a word is repeated. So I can use frequency distribution. So let me first label there that what I'm trying to do. So we are trying to find the frequency, and here we are. So from NLTK, from NLTK dot. Now another module I have to call that is called probability. Probability, and import frequency distribution. You can plot it also. And the tokens we already have, so we have to use the tokens only, then only it will be able to find the frequency. So f distribution is equal to frequency distribution, and tokens are in tks I'll use, and I can print the frequency. distribution, but it won't come. So let's see how it is going to be there. So let's see, and let me see if I can convert it into a list and see. See, frequency with 2 samples and 2 outcomes. It's just giving me like this. So let me see if I can convert it into a list and display it, the function. So ftest, or I can find extract. Actually we have other functions, you can see that. This is taking the first one. I want the tokens of this one. I'll have to run it again. Now I will find the tokens, and now I'll find the frequency distribution. I'll extract and you'll see. This won't actually show you anything. I'll just extract it and then I'll show you. We have a command to extract. So most common we'll find print if dist dot most common. It is giving me some error. Is it okay? Yeah, it is okay. Let's say 2. I don't see any of that coming. A and on is repeated twice, otherwise I don't see any of the word being repeated there. Let's see, frequency distribution is there or not. 3 on and dot is there. Okay, twice, thrice. Let me increase it to 4. I don't see any. It's only commas and all. These are all punctuations, basically nothing else. So you can see that US is repeated once. It is only once. How many? Basically, I want the repetitions to display. Most common, 5 most common. The US was the first. They are all actually one. They appear only once, so I can actually take some other text and check on that where there is some repetition, or let it be like this only.
So what is that five? Is it the number of time it is repeated?
Number of tokens. How many tokens you want? How many repetitions you want?
Oh,
These are 1, 2, 3, 4, and 5. So if I increase it, there will be one more. How many frequency distributions you want to see? So it will appearance is here, right hand side. Intelligence
oh,
1, US 1, comma repeated twice, dot repeated twice, on repeated twice, and A repeated twice. So I increase that, and these will keep on increasing. The distribution will keep on increasing.
all right.
Okay. It has nothing to do how many times things have appeared. If I give just 2, so only first 2 will be there.
Okay.
So I can find the frequency distribution. I can actually display it. I can plot it. So I can import a matplot. I have the command, so I'll just paste it. And it will give me a plot of how the words are distributed. We have used punctuations also there. You can see that. How many times? AN are twice, and dot and comma. The rest are ones. You can see that the words and all, everything is distributed here. So I can plot it. Frequency distribution 30, cumulative false. Cumulative frequency we are not getting. We can plot that also. I can reduce this. Okay. Words, basically these are number of words. Frequencies of the tokens, you can say. Now the most important part comes is the stop words. There are certain stop words which are there already. We need to clean the data. So in this case, actually, we have a clean data, but in cases where we extract the data directly from, let's say, Twitter or Instagram or some other social media, you will be getting a lot of junk with that, and lot of emoticons, emojis, and all lot of nonsense will be there. You don't want to clean that. You don't want that, and you don't want helping verbs like is, am, are, was, were. You don't want that. You don't want like articles also. So we need some. We have to clean them. So what we normally do is we extract it. Regular expression we used to have a reg x, that is what we call, and we only extracted the alphabets A to Z. But in that case also these articles like a and the, your helping verbs like is, am, are, was, were, and all, they will be there. So I don't want them because they don't make any sense to me. I just want the words, right? So for that, let's see, we have in NLTK we have stop words also, and we can download the stop words and see what all stop words are there so that we can clean up the data. So let's have this, and the corpus can be any. I think NLTK supports 120 languages. We'll have to check. So we have downloaded the stop words, and we'll see what is there in the stop words. So from NLTK corpus, import stop words. I'll just paste it. Sometimes the typing actually gets you error, so we have that. Okay, from NLTK corpus, import stop words. Stop words is equal to set stopwords.word English. That is, I want English words only, and print it. So we have other languages also supported by NLTK, and these are the stop words. You can see am, aren't, while, which, that, himself, hadn't, do, there, don't, should have, wave, were, before. These are the words which are actually meaningless as such, which won't make much difference or sense if I want to analyze the text, because rest it will take care of. So I just want to clean it up, and that is important. Cleaning up the data is important in any processing, whether it is image, whether it is textual data or any other data. So we have to clean up the data. We have to actually remove the unwanted data from it, right? And that is what we call noise. And this word noise has come from image actually. Images have noises, that is the dots, pixels, whatever, or sometimes it is blurred or like that. So that is called a noise. But in that word has gone into everything, like a textual data also, or a numeric data also, and we whatever is not required is called a noise. We just have to clean that. It's good that they don't call it pollution, they can call that also. And let me show you some other purpose it has. French. So all we have to do is English, French, whichever I want, I can see. You can see that this is what is there in French. It is more or less like your one minute. Okay, now let me print it. This is French. So you can see that French corpus is also there. So you can try it and see what all corpus we are using. And now we have to remove the stop words, and that is more important to us. So we have the corpus already, and what we have to do, we have to remove it. So let's put it here. We have to, we have already imported the things. Now I want a list. So I want a filtered sentence. Normally your variables should not be A, B, C, D, because if you do that, then later you will not be able to actually find out why you used the variable. What is the meaning of that variable? What is the variable doing? Just by looking at the variable, you should be able to understand what the variable is doing. So you can see that it is filtered sentence. So if I use it later, I will know that. Okay. Now I have to read the sentences for W in tokens. I have what TK. I have a TK. I think I have used TK. Let me see. I have used TK. I think I have used TK. Yeah. Word tokenizer. I think I've used TKS. I have used TKS. Yeah. TK. That is why it is giving me errors. Now I'll just paste this. What I'm doing is, if the word is not in the stop words, if W dot lower, not in stop words. W is the tokens which it is reading. That is from here. Okay, from here you can say TKS, US and all. So if it is not in the token stop words, okay. So what I'll do is I'll just store it into this list. So filtered sentence dot append W. W is appended to the filtered sentence. It is very simple. You have the tokens, you have the stop words, sorry, and you have the tokens. Now you check if the token appears in the stop words. If it appears, that means it is not required. So I want to be appending it. So if it is not in the stop words, then what I'm doing is I'm storing it in a list, and that is what I'm doing. Filter dot sentence dot append W. That's all, and I can filter out the sentence. Rest is printing only. Tokenized sentence, US intelligence, believe it was there. A is gone. See, rapid is there. And on is gone. Was gone. Also is there. You can increase the words. Am gone. The gone. They're all gone. Right? And you can see the length also. And I can print the length. Okay. Length of EKS. We know it was 44. And length of filtered sentence. Let's see that. 44, now 32. 12 gone. So 12 words are removed. We normally actually work on using words which are frequently there in the sentence. So normally we do that.
So can we modify the stop words, like the words which we want or
Then
don't?
you'll have to, yeah, you can do that. You have the list, right? You have the list of words. This list is there. Stop words is there. Okay, this is the list now.
Yes, yes.
If you want to change it, you can change it. You can add.
Okay,
You can add.
okay.
So you have already extracted, na? So when you have extracted, it is there in the variable, so you can always modify that.
Yes, sir. Yes, sir.
You can always append. You can convert it into a list, and then you can append. Okay, so you can do that. No issues.
All right.
Okay, now two more important things which we want is we want the base word of a word. Like when I say we have parts of words, like we have go, gone, go, went, gone. Okay, first form, second form, and the third form. Okay, present participle form or past participle form, ing form is also there. So I don't want that. I just want the base word. That is the first one. That is go. I don't want the went. I don't want gone. Okay, so for that we have two things like lexical normalization. Okay, and stemming we can actually like you have connected, we will get connect. Okay, so we have two things, lexical normalization and we have stemming. So for that what we need is, I'll just use my example here. Lexical normalization, perform stemming, and limitization. Okay, so NLTK download, we have a word net. We have to download this word net. It has to be downloaded first. Okay, then only you can do that. Now from NLTK stem word net, import word net limitizer. Okay, so 1 minute. Okay. Now you create an object. Create an object for word net limitizer lim, and then from porter stemmer you called stemming words. So limitizers and stemmers, two things we have, and we'll see the difference what it does. Okay, again we have an object for that. You're calling the handle, I call it a handle, stem and lim. Word net limitizer, because you don't want to use the entire word porter stemmer dot. Okay, the word is flying, suppose. Okay, but what limitization would do and what stemming would do, lem dot limitize word v, and stem dot word stem word, stem dot stem word. Let me run it and show you first. It will download first. So limitized word is fly, and stemmed word is fly, fli. Okay, fly and fli. So actually limitization gives you the base of that, and fly actually converts it into something else also. You can see that it is fli. So I can check with some other words. Okay. So what we get is conduct in both the things, not in here. It was fli and it is fly in that case, but it is conducting, conducted. If I use, instead of conducting, I use conducted also. And if I use, they're all verbs actually, so we are using, so it will be like that only. Okay, so stemming part of NLP is national. First is your cleaning, that is frequency distribution. We have tokenization first, then limitization, then removing the stop words, cleaning the data basically, then limitization or stemming, and then we have something called we have to find the part of speech. And this is interesting, if you do not understand what grammatically things are, this is going to tell you part of a speech. It gives you adjectives, verbs, adverbs, nouns, pronouns, what is the text all about. It will give you that, so don't have to worry whether it is a verb or what. Just give the text to your here, part of speech, and you will find it. So we have another sentence, and NLTK, I'm just tokenizing it into words, because without tokenizing, I can't actually work on it. So first step is always tokenize. Now I want part of a speech. It is for that I have to download average percentage tagger. Okay, and then I have to create the tokens. I have to put the tokens there. So first you have to download this. Download. Okay. NLTK is huge library, so whatever is required, we can download that. So we don't have to download everything. Now you can see that NLTK dot part of speech. We have used pos tag. This pos tag is actually part of speech tag, comes from averaged percentage tagger. So now part of speech, you can see that in NP. I'll have to first let me post paste that. Let me give you what is what. Otherwise, you will not be able to understand. Paste and let me show you. This I have actually used already, so I'm just pasting from this, so I don't have to. Okay, CC is coordinating conjunction, CD is cardinal digit, DT is determiner, X is extensional there, and then FW is a foreign word, IN is preposition, JJ is adjectives or big adjective, JJR is adjective, comparative, bigger, JJS adjective, superlative, big, bigger, biggest, na? So JJ, JJR, and JJS. They are all adjectives. One is big, bigger, biggest, like that. Superlatives, comparative superlatives, and all. LS is list marker, and MD is model, NN is noun, NNS is noun plural, and NNP is proper noun, NNPS is proper noun plural, and all this is the part of POS is possessive ending, then personal pronoun, and all. You can see that. Verbs, BB verb, interjunctions to WRP is verb only, adverb only. So we have a lot of things. You can see that. And your sentence, your first has to be broken into tokens, and these tokens, when you use it, now just have to pass on to an LTK post tag, and it will convert it into this. You can see that every word is now marked. It is what type of speech, it is part of speech. POS is part of speech. As simple as that. Just have to import the required module. Once the module is there, you can simply put the text in that and you'll get the output. Right? So this is one part. Let's see. Okay. Now I'll be doing something interesting. It is called sentiment analysis. Let's explain that first and then we can go ahead with that. Let's actually copy an image. It is a big one. Taking time. One. Okay, done. I would be requiring data for this, but I'll put it. Let me just click outside. And here you are. You can see this. So, 1 minute. So, sentiment analysis, that is what I was talking about. You can emotions, you can find the sentiments, and what the feedback. You suppose it is mostly used by the companies to understand the response of the people on social media. So what I normally would do is I'll collect my data from let's say suppose Twitter, that is easy to collect, or from Facebook, or from Instagram, or any other social media which has an API and which allows my code to read that. So I would be using this, and I'll just pass on my data. But for that, first is the pre-processing part and then the feature engineering part. The two parts. That is first part we have seen. In this pre-processing, we have to remove the stop words, stemming, and then you get the word, and then you have to find the features. So bag of words, we have TF, IDF, we have word embedding, we have then model building and model evaluation. These are the processes through which the text has to be passed, and then you can get your sentiment analysis. Analysis of the sentiment, that doesn't mean that you are sad or you are happy or what. These are actually emotions. So don't confuse between emotions and sentiments. Emotions are your expressions, and sentiments are your feelings of liking, unliking something, fear, disgust, anger, happy, mood basically. Sentiment is your mood basically. Okay, so and your sentiment actually helps you to understand your feedback of the product. So suppose someone launches a new mobile phone. Let's say Samsung launches a new mobile or iPhone launches 14, and it wants the review of the people. So reviews, it's not easy to get actually, because there is thousands and thousands of texts all around the web. So suppose I target Twitter. This is where actually a lot of uh, exchanges are there. People heated arguments or soft arguments, everything is there. So if I take it from there up, I collect my data from Twitter. I have to clean it first. So that is the pre-processing of the text, and then I can use different methods to understand the sentiment of the people and to understand how people like the product, or they like or they do not like. So what happens, it's not necessary that you get a new review, good review. Like when I normally buy something, a company asks me to give a review. Suppose I buy something from Amazon or Flipkart, they will ask me to give a review. So my review depends on my mood. I want to give a good review or a bad review, depends on me. And on based on that, if people try buying it, so they'll say, okay, they'll see the stars. Oh, this is not good. I should not be buying it, but the product is good. So if you want to actually analyze it, so you have to get into the real world. And the real world is your social media, not actually real, it is also a fake one. But most of that, like reviews and all, if they're there, we have to ignore few things. So that is where the pre-processing is required. So we pre-process it, we just ignore few things and get try to get some analysis of the data. Because or even if some companies, they conduct surveys. Even if you get surveys and if you've got millions of responses, it is not possible manually to find out what is right, what is wrong. It wouldn't be possible, right? So we have NLP there, natural language processing, text analysis, sentiment analysis in that. So sentiment analysis is a part of text analysis only. And here comes your machine learning also, bag of words and all. This is from where we start the AI part. We have actually taken AI also earlier also, but application I'm talking about how we apply. Now let me see if I have the data with me, train.tsv. So I'll share that data with you also. Okay, let me find out. I think I have it here on my system, otherwise I can always get it. I actually put it in a folder, so I'm sure it is there. Swim train is there. Put it somewhere. 1 minute. I think it is there on my GitHub also. I think I have uploaded there. So let me get it in there. Okay. Otherwise, I'll have to find out. I need specific data. So it is train. Let me see what was the name. It was train.tsv. Okay. PQRS. It is there. Yeah, it is there. So I can find out. I can download this. I can download my TSV file. View, no, I don't want to view it. I just want to download it. So it has your, I'll show you once I upload. Okay. This is a TSV file, so you don't have to worry about anything. It shows me it is saving as a text file. I don't want this to be saved as a text file. I want it to be text file. It is a TSV file. Yeah. It is saving it as a text file. Let me change it to a TSV file. That is why it is showing me like that. All right. Let me see if I can change that. Notepad, I don't want that. It is saving as a text file. I just wanted to download that. Let me see 1 minute. I'll download from here. Go to file. Just download from here. Train. Is train. Okay, so it is not showing me there. Interesting. I'll have to change it. Let me upload it and then I'll change it. Okay, let's upload it. Not a big file, but it is taking it as a text file, which I don't want. So let me see if I can change the extension. I just want txt, sorry, tsv. Why? Till then it uploads. Let me see if I can change that here. Okay, view it as raw. Oh yeah, I've been able to save it now. It was taking it as a raw file, so I have uploaded already. So let's see. Yeah, I can change it. Rename the file. I don't want this txt extension. Let me see if it is opening. Right inside. If it opens, then fine. Otherwise, I'll upload again. I have the file now. It is giving me. It is taking a lot of time. It's not a big file. How many records? This is 8 MB file, so it should not take that much time. It is giving me txt here. 1 minute. Let me remove it and upload again. No point wasting time here. Delete the file. Okay. Delete this also. Let me upload again. I have a TSV file now. This is extension looks like Excel only, TSV. Similar to your CSV, it is TSV, text. format. So let's upload this, and till then I can put the command import pandas as PD. Sometimes Colab crashes when you have big data, so keep that also in mind. It's uploaded. Train the TSP, or is it still uploading it? But it's uploaded, then it can show, otherwise it will just, because this I can't see this complete thing. So let me run the command. It will show me whether it is no, the file is not there yet. It has to be uploaded. It is uploading. It's okay, but it is working also. The circle is going on, so the circle has to stop. Then only the entire file will be there. Although the data is visible now, you can see that. So train.tsv file, yeah, it is there now. Fine, no issues. Complete. Okay, you can see this. This has phrase ID, sentence ID. Then you have a phrase. Then you have a sentiment. Okay, so this is a train.tsv file. You can see sentiment as numbers, and I can get information for that. I don't want. I just have the data.info. I want to get the information. Phrase ID. How many records are there? Basically, it tells you how many sentiments are there, which is 99,734 elements are there, and we can find the sentiment count. If I just want to know how many sentiments are there, find separately. Okay, I can find data.sentiment, that is the sentiment here, dot value counts. You can see that 2, 3, 1, 4, and 0. These are the numbers given to the sentiments 0, 1, 2, 3, 4. So 0 has 442 entries, 4 has 5,720, and so on. You can see that. So you can find for any of the fields. So now I'll show you what actually all these mean. In this case, just basically more emotions. The data has 5 sentiment labels: negative, somewhat negative, neutral, somewhat positive, and positive. 0, 1, 2, 3, 4. That is what the labels are all about. That is what I was saying. We normally convert it into integers. Now you can plot and see also. Simple. I'm just analyzing and not doing anything right now. Just port and you can plot. Review sentiments 0, 1, 2, 3, and 4. So 2, that is you can see that neutral sentiment is neutral about any the product or whatever the thing is. Plot and see. But these are actually already there. We have already given the sentence, but we have something now, that is feature generation using Bag-of-words. We need to extract the features, and we have different things, and most common is your Bag-of-words. Bag-of-words, that is the most common, and it is split first. What Bag-of-words has to do first, split the document into tokens, assign the weight. That is from frequency. Normally we find the weights, how many times things have come and all, and then creating a document, a matrix, so that you can understand the tokens, how they are arranged, and then find out and the sentiment. So you have to vectorize the data. Actually, like this is these are the vectors which is already there, numbers. So we have to vectorize the data. This you have to vectorize so that you can find the patterns in it. That is vectorization. When I say we are converting that into integers. So we have three vectorizers. One is count vectorization, one is hash, and one is TF-IDF vectorizer. The count vectorizer is the most straightforward, simply converts into numbers and the weights. And then hash vectorizer is designed to be a memory effective. That is, you minimize the memory usage, and feature names can no longer be retrieved, but it just you cannot retrieve the feature names. TF-IDF, normally we use that most of the time. It is a frequency inverse document frequency. TF-IDF is term frequency inverse document frequency. That is the full form of TF-IDF. That is weight assigned to each token not only depends on the frequency but also on the recurrence, how many times it recurs, and in the entire corpora. Okay, it's not only the sentence. We are not talking when we are doing sentiment analysis, not only one sentence, it is a corpora. Corpora, when we say, it is the data set. Okay, collection of the records, data. Okay, so let's see what we do, how we use that. Scikit we use, so sklearn we'll be using now. Sklearn is already there for tokenization. So we have sklearn now, scikit learn or sklearn we have. Then NLTK we already had the tokenize, regular expression tokenizer we have called, and here we have called count vectorizer. Okay, so tokenizer to remove the unwanted elements, tokenizer regular expression tokenizer RA to Z. That is, it will just retain the alphabets and the numbers. This is what regular expression tokenizer is doing. Telling by code that only alphabets and numbers are to be removed, whether they are in small case or uppercase, nothing else will be there. So token is equal to regular expression tokenizer A to Z, and all. Now 09 also. Then count vectorizer, we are just defining these. Okay, these are just defining the handles. We are just creating the handles so that we can use them later. Now we are defining this count vectorizer lowercase true. Stop words we are using English. N-gram range is 1 N-gram is number of grams, that is number of frequency basically. Tokenizer is tokens dot tokenize. We have already used the tokenizer here, so we have to give what tokenizer it is going to use. So tokens, that is only numbers and alphabets it is going to use. Now what we are doing is cv.fit transformer data and phrase. We have data we already have, and let me run it and show you. We already have the text. This is what it gives. I'll make it more meaningful. How many times? 0, 1, 2, 4, 5, 7, and then you can see that it is all converted into numbers. 9, 1, they are numbers basically, and these are the frequencies also. Text count, how many times this occurs, gives you that. So we have a fit transform. We have called, no, we don't need that. We are calling from here count vectorizer. I'll see if I can get you the syntax for that. I need bigger data. Okay. Data we have, right? Yeah, data we have, data dot hit. It is taking from here only, and what we are taking it is the phrase. So phrase is converted into numbers. This phrase cv.fit transform. What it is doing is it is converting the phrase into numbers. And how it does that, this phrase, the entire word, the sentence, it is the convert vectorizer, that is sentence we are converting, and from phrase we could have there's no other text actually, this is the phrase, so it is just converting it into numbers or vectorizing it, and you can see that how many times one thing comes, see that. Okay, so these numbers are actually generated uh, according to the weight. So weights are assigned and it converts it. Normally what I do, when I use my own vectorizer, what I do is I convert each alphabet into its ASCII equivalent, and then I just keep on appending that or keep on adding it. Either I append or I add. So I normally add it. So whatever number comes, that will be my token vectorization, vector, sorry, vector of that particular word. So I normally do this, and but they have a different algorithm. They use the weights. They put the weights for each alphabets and all, and then accordingly they calculate the vectors. So these are converted now. Text, the phrases which were there. There was somewhere around 9,000 something phrases. So they have been converted now into tokens. Okay, so I'll show you. Now we have to apply to find the sentiment. It has been converted. Now what is required? For machine learning, what we have to split the data into training set and testing set. Now, for that we need from SQL learn model selection, import, train, test, split. This module is already there, so I don't have to break it. Otherwise, normally what I could do is, suppose I have 10,000 records, so I'll take 7,000 the training set and 30,000 3,000 as a testing set, right? Testing is evaluations, validation set also. Now, but here we have the module, so I don't have to. Module is there, test split. Now, text count, that is the count we have already found. Text counts, that is what we have to split. Data, we are putting only now the sentiment, that is 0, 1, 2, 3, 4. Test size is 0.3, that is 30% training set, 70% training set and 30% testing set, that is the test size, and random state is 1. Now all these algorithms, I'll just run it and explain it to them. All the machine learning algorithms or deep learning algorithms and all, they use they are random actually. So the data is split randomly, and so if you want the same results to come, you have to fix your random state. Okay, that means it should not give me a different split next time. So if I fix my random state to any number, I normally tell my students to put their date of birth there, so that they remember that what random state they gave later on. So if we use the random state, I have used random state 1, I can use random state any. Okay, any number I can give in that. So to remember, normally date of birth, year of birth we give, so that we can remember later on. And now if I run it again with the same random state, my same split will come. And that is the catch with randoms. Randoms are generating actually random values, numbers. But if you fix it, you can get the same results. And this is how hackers can also break into your system. If you give fixed random state, they will just break into it. Those numbers, you can always guess. Now, now you have to build the model. Predictive analysis we are doing. We are using a multi-anomial Nair bias. This is a classifier we are using. This is a machine learning thing we are doing now. The NB we are doing Nair bias classifier. for predicting the sentiments or just classifying the records, you can say. So data we have, all we have to do is to just call my classifier. So from sklearn.nybias import multinomial NB. Multinomial nybias classifier I have called. I can call actually simply NB also, nybias also, but I'm using this. I can use many. I will explain that later. There will be many. So just trying to show you practically how things will go. Okay. Now, for evaluation purpose, I need matrices. So from sklearn import matrix, I'll do that. Now, I have multinomial NB, so I can simply fit it on my training set X chain and Y train. X chain will be having the data, and Y train will be having the labels numbers 1, 2, 3, 4, which are coming on the right hand side. And now I can predict using predicted CLF, that is the model we have compiled dot predict X test. On the testing side, we have to predict. And let's see what accuracy we get. We're just calculating the accuracy. We're not calculating in sentiment. It is already there. The sentiment is already there, but something is missing. So let me see if it is what is missing. Nan, oh, there's a nan there. This data has nan, so I won't be able to compile that. D type, there is somewhere nan gone. That is a blank. I have some blanks there, so I'll have to clean it. Let me clean it first. Contains nan. That is what I was telling you that day also. Set nan infinity or a value to larger for D type float 64, which is not taking that. So let me see. It should not have happened. I've used the same data set earlier also, but it happens. Let me check if I have some nan there. I'll have to open it on my system and check the data. So let me check it. I'll upload the data again then. Some blank must have gone somewhere, but maybe some other reason also. The 90,000 records, it will take time. So let's see if we have in the number sentiments, it shouldn't be there. There should not be any blanks. I can count the nans also. Okay, there are numbers actually. Oh, there are blanks. Yes, we have the blanks. Yes, yeah, we have some blanks. When it split the text, then okay, it has lot of things. Lot of garbage is there. Right, it has dots, commas. All right, data is not very clean. Let me see. I use a clean data. Oh, okay. We have, yeah. There are no blanks, but there are actually, yeah, there is one blank. I can find this. Remove. I'll try with the this removing the blank if it can work. It won't actually work without removing the blanks. I'm doing it manually. I can do it using the code also. You won't be able to see what I'm doing, but it's okay. Just remove something which is not actually there. Quotations remove there. I can use the command to remove it also. Drop NA is there. There's certain data here where there are simple dots, nothing else at all, commas, apostrophes. So that will going to create me a problem. So it is better that I remove that. What I can do is I can sort it out. Put the filter. You won't be able to see what I'm doing, so you just have a look of what we're doing right now. Sort. I don't think now we have any blanks here, but oh, they're very interesting records. It's a lot of garbage. I'll show you later that how I can remove it using the commands. We have certain things, but it should not have taken it because okay, fine. We did not remove the stop words. That is what happens with the text. Common problems. Face it every day. This is not a benchmark data set. Normally, benchmark data sets won't have this issue at all. Just removing few things. The records will be lesser now, but that's okay because they are meaningless. You don't have any meaning for the dots or something like that. Just sorting on the numbers, which is not making any sense to me. I've used it now. Let me more or less clean. Let me remove this. Delete file. Okay. So I've put the raw file there. So let me have it now. It is uploading. Hopefully it will be okay now. Otherwise I'll have to clean it again. Without cleaning it won't work. Mhm. It is still uploading. Let it upload. I can use this tokens. Where is the data? Here you are. I have to run the commands again. And if it gives, then I can use this also. Data to data dot drop any. Give the command drop drop any. Oh, sorry. Data is uploaded. I can give access is equal to column and how is it to any, and I can replace that if I want. This we did earlier also. This any command. Right. Let me run it and see if it is working fine. No, it is not taking any. Access is equal to columns. It is not taking that. It should. Okay, there is one bracket problem. Okay, not with the access. There was an extra. Yeah, that's fine. It is giving me non-null data information. It is showing me that there is no null there. Still, there's some values which are bigger. I can change the data set also, but that's not a solution. There may be blank somewhere here also in the tokens. It should work. It's just keeping here. So the accuracy it was giving, so I can. Okay, now it's fine. So I have dropped that. You can see that. I've done it manually also, and I've dropped it also. So any data which is not required has to be dropped. You can use it drop NA, and the records have been decreased. You can see that. So there were a lot of nulls there, but although it was not showing me any null, but oh, there must be. I did not check this count of non-null. Yeah, non-null is okay. This is okay, but I did not check this one. There, there must be some. Anyway, so drop any command is there, and the column is axis. So row wise you can drop it, or column wise you can drop it. So you can access equal to 0, or rows you can give, or you simply say columns. And how is any, whatever you see is null, just drop it, or you can replace. So this is done, and now you can see that accuracy 60%. This is very bad accuracy actually, uh, although it is a benchmark data set, but you can see that the accuracy is not good. Okay, so you can generate the features using some other option also. We can generate using we have election these days, so we have a lot of nonsense going on. So Monday we have elections. That's why everybody is interested in this. Now I'll be using TF IDF. Normally we use this term frequency. TF is term frequency in verse, and I said also so Bag-of-words BOW. Okay, so frequency is basically the output of the Bag-of-words model. So it uses a Bag-of-words small model. So very commonly used machine learning algorithm. Bag-of-words is a collection of words basically. You can say that. And Bag-of-words we use even in image processing also. So we are just what we are doing is we have called TF-ID vectorizer handle, put it on phrase, and why we have not printed. Let me print text TF. You can see the vectors. It is different from what it was earlier. You can see that. Okay. Now we have for the same thing. We have to split it, and now I'll change the random state. So we have called train test split. In test split, text count data is again sentiment, text size is 0.3. Now random state is 1, 2, 3. So I don't want the same random state, so I've used this, and I can show you actually what is there in the text. One data print x train. What is there in x train? See the tokens, and there are many, and the labels print. So, sorry, my train, I think it is small only. I used small. These are standard numbers which we use. You can see the train. These are the labels only. These are the tokens here. Vectorization is done, and although it may not actually show you anything good results, not expected that the results would be very good, but NiamBio skills doesn't give you very good results also. X test will be same, and Y test will be your tokens. Sorry, labels. Sorry, not tokens. Tokens are here. Y test. See the data which is there stored in it. See numbers only. So it is actually 30 40 30 70 split is 30 70. You can increase the split and show you that the data may, your results may change. They may be better. Again, same thing. You have to call NB again. Same we are calling. Only thing is we have changed the vectorization to TF-IDF. Everything is same. Only vectorizer now is TF-IDF. Classifier is again multinomial NV. You can use others also. Here you can change it. Okay, we'll see that. But let me see if it is not giving me any errors first. Yeah, it is not. So you can see that it is again 60%, 60.9. And here it was again 60 or something, something. So even after vectorization, it is 60.58. It is 60.9, little better, but still not good. Anything above, actually, when we classify, anything above 60 is okay, acceptable, but it is not good. Okay, so let me try this with better split. Let me make it 20. 80, 20, 80 in the training set and 20 in the testing set. So I will not print it now. I'll just run the command. Yeah, I just have to classify. Classification is very easy. It has increased. You can see that it is now 61%. And why it increased? Because you have more data in your training set, similar set. In testing, split is there. So when we split the data, uh, in let's say if I make it 60-40, accuracy will drop. If I am close to your 100%, if I give it 80-20, it is good. If I give it 90-10, we'll try with that 90-10, it will be better. Or it may uh, not be. It is possible. May not be better because there may be some overlapping. Data overlapping may be there. So for a simple machine learning, this is a machine learning algorithm called multinomial non-bias classifier. All you have to do is this particular code, just 5-6 lines of code, just to call the classifier. Then this is only for actually the sake of this one. This is for calculations only. What calculations we have, and it already has the sentiments, so we are not finding the sentiments at all. So if I put a new data, then I can find it, but it is not. The aim was to just classify the sentiments and see whether it is actually accurate or not. So what is the class? The classification done of the sentiments may not be accurate, as accurate as it should be. Like these days, when we classify and we find the accuracy, it is close to 99%, 98%, 99, 98, and in some cases it is even 100% accurate, right? And but in this case, you can see that the accuracy is not very good. It is, but it is above 60, so acceptable. Anything above 60 is acceptable. Anything below 60 is not, right? So you have the simple way of doing is, but first thing is you have to clean your data. You have to split the data. You tokenize the data. Okay, so what you are doing is you are cleaning the data, then you are vectorizing the data, and then you are splitting the data. Yeah, you are splitting the data into training set and testing set, and you are just simply applying the classifier. So this is what is machine learning is all about, and nothing, not a very, nothing much. It's not a rocket science basically. When we say that we are applying AI and all big words, but machine learning is very basic actually. We can do wonders with transformers, or we can do wonders with your deep learning. But machine learning is limited to this only. Very simple. But we'll be talking about the theoretical part and try to understand the algorithms later. But first, I believe is to apply and check how they work. Practically, if you apply that, it makes more sense to me. But anyway, that's okay. So this is NLP, Natural Language Processing is required. So we are working on the text, but the accuracy could be more with your numbers. These are tokenizations which we have done. We have converted into tokens now, but it could be better if you're using the integer data sets, which is already there. Okay. Now, mm, let me share it. Let me first save it because it will be too much. I am too fast. I think I am feeling that I'm fast. So you can always be frank and tell me that I'm fast because I already have it. So I just copy and paste it. I don't waste the time in the typing. There's no point in wasting time in typing when I have already tested that. I normally test it before the class so that I don't get errors, but I still got an error today. But I did not test the data set. Okay, this is interesting. So let me share it with you. It will take time for you to actually understand it, and then you can revert to me with your questions. So first, let me share this with you, and you have a lot of backlogs also. I don't want any backlogs. So let me share first. Okay, so let me stop the recording. It is not required. I'm just sharing.